In this video, we're going to talk about logarithms, and we're going to talk about quite a few things with logarithms. First, we're going to talk about how to say them and how they look. Then we're going to talk about some intuition about what logarithms are. And then finally, we're going to talk about how to compute logarithms. All right, so let's first talk about how to say them and what they look like. And I'm spending time doing this because it's kind of a unique operation that you probably haven't really dealt with anything similar to it before, right? So this is how they look like. I have two examples here. And let's talk about how we would say them, right? I would say this as log base 8 of 64, right? And I would read this one like this, log base 6 of 216. Sometimes you'll see parentheses around the second number, and that's to emphasize this idea that we're taking the log of this number. Right? We're taking the log of 64, the log of 216. And then the base, it's kind of like that's telling you what kind of log we're taking. Okay? The other thing I want you to notice is that when I write a logarithm, this log is just in regular letters and the 64 is just regular numbers. But then this 8, the base, is a small 8, and it's lowered. Same thing over here, log and 216, those are regular letters and numbers, but the 6 is a small 6 that's been lowered. Okay? And again, you're going to have to practice this, but the way we read this is log base 8 of 64. All right, so now let's kind of develop some intuition about what logarithms are. And the best way to understand what they are is to see that they are the inverse of an exponential function. Right? Please write this down in your notes. The inverse of an exponential function is a logarithmic function, right? Or that's just a function with a logarithm in it, right? And what I'm trying to get at here is that we've done lots of things with inverses, right? We've seen the idea that the inverse of addition is subtraction. The inverse of multiplication is division. The inverse of cubing something, right? If I had x cubed, the inverse of that would be to take the cube root, right? These are all inverse operations. Well, it's the same thing with an exponential function. It has an inverse operation, right? And it's the logarithm. So if I had this function f of x equals 2 to the x, this would be its inverse, log base 2 of x. Okay? These two are inverse functions. So let me show you now how these inverse operations play out. And you'll see how they undo each other. Okay? So again, same two functions. F of x equals 2 to the x, and then the inverse is this, log base 2 of x. Right? So f of 3, we could easily calculate that. That is just 2 to the third, and 2 to the third is 8. So what does that mean for the inverse? Right, that means that f inverse of 8 should be 3, right? Because the inputs and outputs just reverse, right? And so how would I write that out in logarithmic form, right? What that tells me is that the log base 2 of 8 is equal to 3, right? When I input 3, that's the exponent here, 2 to the third is 8. But then the inverse is this. Log base 2 of 8 gets me back to 3. Okay, and it's okay if you're not completely comfortable with how to calculate that just yet, but I want you to at least kind of see this inverse relationship. Okay, let's look at one other example here. Imagine I have 16 and I want to input that into my inverse function. Right? In other words, I would want to calculate log base 2 of 16. Right? Well, what is that going to be? It turns out that log base 2 of 16 is 4. Right? And you might think, why is that true? Well, I think it should be obvious if you think about the original function. Right? If f inverse of 16 equals 4, well, that means when I input 4 into the original function, I should get back to 16. Let's see if that works. Right? Let's calculate f of 4. F of 4 is 2 to the 4th, and 2 to the 4th is 16. That's right. 2 times 2 times 2 times 2 is 16. right? So f of 4 equals 16, 2 to the 4th is 16, and that means for the inverse, log base 2 of 16 is 4. Okay, so now we're going to kind of do this formally and talk about how to formally calculate a logarithm. All right, here's the definition that I want you to have in your notes. The logarithm of a number is the exponent to which the base must be raised to produce that number. Okay, that's kind of a mouthful. Let me read that again. The logarithm of a number is the exponent to which the base must be raised to produce that number. Okay, still might be a little bit confusing, so let's take a look at this example. Log base 8 of 64, right? This logarithm is going to be equal to the exponent to which we have to raise 8 to get 64. Or in other words, you can kind of think about this, right? Imagine kind of, right, kind of drawing a little like idea box to the side, right? Our logarithm is going to be the exponent that I have to raise 8 to in order to get 64, right? And obviously this exponent here would have to be 2. So log base 8 of 64 is 2, because 2 is the exponent to which I raise 8 to get 64. Let's look at another example. Log base 6 of 216. Okay, so if I think about my little thought bubble here, right, I need to think 6 to some exponent would get me 216. Right? The logarithm is equal to the exponent to which I raise my base of 6 to get 216. And the answer is 3, because 6 cubed is 216. Two other ones. Right? Log base 3 of 81 and log base 9 of 1. I would like you to pause and see if you can figure these out. Right? So here I'm trying to figure out, let me kind of set it up. I want you to think about what exponent, I'm looking for the exponent to which I need to raise my base 3 in order to get 81. Right? Pause and try to figure these out, please. All right, hopefully you were successful. 5. Log base 3 of 81 is 4. Why is that? Because 4 is the exponent to which I need to raise 3 in order to get 81. Right? What about 6? The answer is 0. Because 0 is the exponent to which I need to raise 9 in order to get 1. Or in other words, 9 to the 0 is equal to 1. Right? 0 is the exponent to which I need to raise my 9, that's the base, to get 1. All right, you have 3 more that you are going to try on your own, and we will check these in class.